All right, so really, you kind of have already learned all the things you need to learn to do this lesson. And so we're going to review them real quick. So if you know all these things and you just can do basic equation solving, then you already know how to do this. So if you have two logarithms separated by addition, what can you use to condense it to one logarithm? Multiplication. So that would be log base b of x times y. What if they're separated by division? Separated by subtraction. You're going to use division. You need to be writing this down. Do you need a pencil? Thanks. All right, another property is that you have log of something raised to a power. What are you going to do with that power? Put it in the front and make it multiplication. Is something wrong? Okay. All right, and this next one is not really a property, but it's something we've talked about before. And there was a problem on your assignment yesterday, the very first one that a lot of people missed. It was log base 7 of 7 to the 11. A lot of people said that was 1. What is it actually? Yeah. So if the base, these are the same, the answer is just going to be whatever that exponent is. So it's like 7 to what power gives you 7 to the 11th power. So log base b of b to the a, it's just going to be a. All right, and then finally, the very first thing we learned about logarithms was how to write them in exponential form. So if I have log base b of x equals a, what would that be in exponential form? B to the a equals x. All right, so I think this year we've talked about extraneous solutions. I can't remember what type of equation it was, maybe rational or radical equations. But do you know what extraneous solutions are? Anybody? All right, they're false solutions. And it's a false solution where you do everything you're supposed to do, but when you get a number, you plug it back in. It just gives you something that's untrue, or it gives you something that gives you an error. So sometimes that happens with logarithmic equations, so we're going to make sure you check solutions. And that's just plugging it in the calculator. It's no big deal. Okay. So all of these things we're doing today are solving logarithmic equations. So it's going to be an equation that has a log. Sometimes it says log, sometimes it has ln, but they all have logarithms. And so the first thing you want to do is isolate the logarithm first. So do whatever kind of property or just basic equation solving stuff, moving things around to isolate the logarithm. Then you're going to decide if it's type 1 or type 2. So type 1 is going to be log equals a number. And whenever it's log equals a number, to solve it, you're going to write in exponential form. And that is the same thing we just did up there. You already know how to do that. Right, and then the other type is type 2, and it is going to be log equals log. And these are actually a little easier to do. So you'd have something like log of 2x equals log of 4. So if they both have the same logarithm, then that means that 2x would have to equal 4. So to solve, you just drop off the logs. So let's solve some of these. All right, so if you were trying to isolate the logarithm on example A, what would you do first? Yes. So that means that log base 3 of x plus 3 squared is equal to 6. Now there are multiple ways we can do this. We could go ahead and write it in exponential form, but it might make it easier for us if we use that property where we can move the power down in the front. I think it's going to be easier if you do it that way. Right, and then we are almost ready. So now we just need to get rid of that 2. So we would just divide by it. And I just decided I was going to put as many 3s as possible in this problem, I guess. Okay, so would you guys say this is type 1 or type 2? Yeah, this is type 1. It's log equals a number. And whenever it's type 1, we're just going to write in exponential form. All right, so we start with the base raised to the power equals that. So 3 to the third is equal to x plus 3. You guys know what 3 to the third is off the top of your head? 27. If you don't, it's okay. You can just plug it in the calculator. All right, and then we'll just subtract that 3. And x is probably 24. It's possible that it's not. Possible it's an extraneous solution. Now these are kind of tricky. When you do log base, you automatically get parentheses. So what you have to do is put that inside of the parentheses the calculator gives you. So that is a little tricky. I'm checking your answer. We are plugging in, what did we say it was, 24? We're going to plug 24 in. So we're going to do log base by doing alpha window 5. And then inside of their parentheses, we're going to open our own parentheses and do x plus 3 squared. And then outside we'll do plus 4. As long as you get... Oh, don't do x, sorry, do 24. There we go. All right, we got 10, so we're right.
I got 7.182.
It's because you did x. Don't do x, do 24. Oh, you did? Well, you're supposed to get 10.
Go ahead.
If you don't get like an error, then you're probably fine. Because that's what happens. You get something that you can't plug back in. All right, let's look at letter B. What would you guys do first on B to isolate the logarithm? Subtract that too. Good. Yeah, it's subtracted. Since it's been added to the logarithm, you're going to subtract it. Whoops. All right. Type 1 or type 2? Type 1 again. When this log equals a number, we're just going to write it in exponential form by doing the base to the exponent equals that. All right, 5 squared is just going to give us 25. We don't need those parentheses anymore. I don't know why I wrote them in that light blue. We don't need them. All right, and then this is just a couple steps by adding 1 and dividing by 2, and x is probably going to be 13. We can double check it. And we get 4, so we're good. All right, so we have 3 more to do on the back. They're a little bit more complicated, I think. We're going to have to use those top 2 properties to be able to do these. All right, so we still want to isolate the logarithm. So to do that, we have to make 2 logarithms condensed to 1 logarithm. And so if those logs are separated by addition, what are we going to use to bring them together? Good. So we're going to multiply 3 times x and 3 times 4. Distributive property. Yes, good job. Okay, so this one is log equals log. Log equals log is type 2. And sometimes at this point, it's a little easier to solve. And so we're just going to drop off the logs and set 3x plus 2, 12, equal to 5x minus 2. Right, and then this is an equation like you guys learned to solve several years ago. So we'll just get our x's together by subtracting the 3x. Move that 2 over by adding it. And then x is probably going to be 7. Now when it's logged with no base, what is the base?
10.
10, good. And we can just use that log button that's beside 7.
We plug in all that, like the original form?
Yes, 7 in for x. Well, plug in what's to the left of the equal sign, and then plug in what's to the right, and make sure you get the same ugly decimal. All right, we get the same ugly decimal, so it's true. Those sides are equal to each other whenever x is 7. All right, you guys okay? All right, a couple more. So same situation here. These are separated. We need to condense them together, but this time, because they're separated by subtraction, we're going to condense them using division. We're also going to take that 3, because we can't condense if there's a power, if there's a number in front. So we're going to move that 3 up to a power. So we're doing kind of a lot in one step.
Is that, oh, okay, yeah.
That's a 2 to the 3rd. All right, so this is another type 2 log equals log. So we're going to drop off the logs. I'm going to go ahead and raise 2 to the 3rd. Yes, so anytime you're solving an equation, there's something in the denominator you don't want, just multiply by it. So we do distribute that 8. And then I'll get my x's on one side by subtracting 8x. And then divide by negative 7, and we get negative 8. All right, so let's see what happens when I put that in for x. So natural log is right beside the 4.
So if you don't get the same thing, does that mean you got it wrong?
It either means you got it wrong, or it's
like
it's an extraneous solution. Probably if you just don't get the same thing, you did something wrong. If you get what we just got here, where we get an error, then it's extraneous. More than likely, that's what happened. Why is negative 8 not going to work? Do you guys remember the restrictions on this part? It's okay. This part right here, the argument can't be negative. It can't be 0. So when I put negative 8 in, you do get 0 for the argument. So it's okay. There's just no solution. These sides of this equation are never going to be equal to each other. So you can see there's a couple on your homework that are no solutions. It happens. Okay, this last one is pretty quick. You guys tell me, what would you do first? Yep. So those logs are separated by addition. We are going to go ahead and condense them. So are we going to write in exponential form, or are we going to drop off the logs? Yeah. If there's not two logs to drop off when you're deciding, then it has to be exponential form. So 2 to the third is equal to 4x. 2 to the third is 8. So x should be 2. I'm just going to go ahead and tell you it is. You can trust me. Oh, we could have done other things too. This right here is just 2. It's fine. It doesn't matter. All right. What questions do you guys have? Okay. I put the answers on the board. I do want you to just know that the answers aren't there. You do need to check your answers in the calculator because sometimes you do get errors. And obviously, you have to show your work if you want to get